I'm going to talk about a lot of different things today. We'll talk about animal emotions. And some people might think, well, that's being anthropomorphic to talk about animal emotions. No, it's neuroscience. One of the big problems we've got in science and in many, many disciplines is everybody stays in their own little stovepipe. You got the veterinarians that got their literature, animal ethology's got their literature, the psychologists have their literature, and nobody reads anybody else's literature. Well, the fact that animals have emotions, some of the first research done on this was done in the 60s. I can remember when I studied general psychology and we studied the rage cat. Stimulate the thalamus of a cat, and he starts hissing in a big rage. But back then they called it sham rage or fake rage. Well, why would it be fake rage? That doesn't make any sense. Because another one of these old experiments, and the Physiological Society is now putting a lot of this stuff online, showed that the cat's rage wasn't fake. They did a clever experiment to show that it wasn't fake. They gave it a stuffed rat, or they gave it a styrofoam block, a square block. It would attack a stuffed rat, but not a styrofoam block, you know, because a styrofoam block is an inanimate object. And even when the thalamus is being stimulated, it knew the difference. Okay, what are some other indicators that animals have emotion? Prozac works on dogs. In fact, dogs right now are being used by researchers as models for studying anxiety and OCD, obsessive-compulsive behavior. See, down in the base of the brain, you've got centers in the brain that drive emotions. These centers in the brain have all been mapped. And some of the research is being done by the National Institutes for Health to study why people get addicted to drugs. They're studying emotional centers in animals. And so to say that animals don't have emotions is kind of stupid. In fact, the one part of the brain that's probably the most the same is the lower centers down in here where those emotional drivers are located. And where we're most different from the animals is all this extra computer we got up here on top. Neurotransmitters are the same. Now, Jack Panskep was one of the first neuroscientists to do a popular book on what he called the core emotional systems. You have fear. Fear circuits in animal brains, human brains have been mapped. If you stimulate the amygdala, the fear center, the animal gets scared. If you stimulate that in people, sometimes it's done during epilepsy surgery, you get the same results. You have rage. Then you have another emotional system, separation anxiety. And it's separate from fear. In fact, you can breed animals that are high fear, low separation anxiety, and vice versa. You know, and that separation anxiety is dog is home alone, it's chewing the house all up. You know, and the mother and the baby are taken apart, and they get really upset. But then you got to have an emotional system to make an animal seek, to make it go out and do stuff. Otherwise, it would cower in a corner. Then you have mother-young nurturing behavior. And then, of course, you got sex. And then you've got play. And interestingly, some research done by Berridge at the National Institutes of Health, he has discovered a system in the brain, it's a switch that actually switches back and forth between do we seek or do we have fear. And I was just on the plane reading this book, a Survivor Club, about how do you survive and things like, you know, planes crashing and stuff like that. And you know, something bad like that's happening, everybody's just kind of looking. That's the seeking mode. Or they can go into complete panic mode. And in the nucleus accumbens of the brain, it can either flip to seek or going into complete fear mode. I had a situation where I avoided an accident on the freeway that really demonstrated how that worked. Some idiot in a little low trailer passed me on the freeway, and a 2x6 board about this long slid off this trailer. And I locked onto it like radar. And it was like floating across the highway like this. And I moved the car over like this, and I slowed down, and I did a perfect straddle on the rumble strip. Managed to avoid a very serious accident. Wasn't scared at all. And then as soon as I had successfully not been killed by this board, the switch in the brain flipped, heart pounding, and every swear word you can imagine was coming out. And I am not going to say the swear words. Okay, you've all seen an animal orient. You know, the deer looks. Okay, what do? Do I keep watching? Or am I going to go into fear mode, or I'm going to do something? And look at the ears of the deer. One is back there looking at the woods. The other ear is pointed at the photographer. Animals watch with their ears, especially animals like deer, your grazing animals, prey species animals, always watching. Well, I did a little thing where I just put a clipboard out into a pen full of cattle, and they'll all come up and sniff the clipboard. That's novelty seeking. And then the wind would blow the paper, and then the cattle would run away. And it was like a switch. Well, back when I did this in 1998, I didn't know about the switch in the nucleus accumbens. That Berridge paper was just published just a couple of years ago. Now, the thing about new things to animals are both scary and attractive. I call it the paradox of novelty. If I put an umbrella out in the middle of a pasture, or I tie a bunch of flags to a fence, cattle and other animals will come up to that. But if I have a horse locked up in a stall and I open an umbrella up in its face, where he can't get away, that's going to be scary. See, if you take novelty and just shove it in the animal's face where they can't get away, it's scary. But if they can voluntarily approach it, that thing that's scary in close quarters is attractive. They'll walk up to that same umbrella if I just put it out in the middle of a field. That's it's kind of the balance between fear and novelty seeking. Now, there's some animals are higher fear, some animals are higher novelty seeking. Same thing with people. Oh, why do people do things like climb up Mount Everest? Because it's there. It's not something I want to do. Or extreme sports. I like to watch extreme sports, but there's no way I would do it. Absolutely no way. Okay, sometimes you have a situation where an animal's doing a lot of abnormal behavior. Dog's chewed up his foot because he's home alone. That's driven by separation anxiety. The zoo cat there pacing all around, that's the seeking system. What does that animal do out in the wild? It walks a long way. It's a big seeker. Polar bears are the same way. Yesterday I was at the Detroit Zoo, and they were doing some really good environmental enrichment for the polar bears. The keepers throw fish in, and the polar bears dive for them. And then you can go down in this glass tunnel underneath and watch them dive for it. It's really cool. And that gets rid of the stereotypic behavior. What do dogs need? They need lots of companionship, people and other dogs, and they need lots of activities for seeking. We have more behavior problems with dogs today than we ever had. When I was a child, all the dogs ran around loose, no behavior problems. Nothing chewed up, nobody bitten, because they were all socialized. And now we've got tons of behavior problems. We don't have as many dogs hit by cars, but we've got zillions and zillions and zillions of behavior problems. Now, if you've got a behavior problem in an animal, you need to figure out which emotional system is driving that behavior. Okay, this is a very interesting experiment that was done with gerbils. And the gerbil was digging. You might have a gerbil at home in your kid's bedroom, and he's digging. So you go, okay, I'm going to give him more dirt. That doesn't satisfy him. The reason why he's digging is he wants cover. Think about how this animal lives out in the wild. And this is where my visual thinking really helps me. See, all of my thinking is visual. My mind works like Google for images. In the HBO movie, Temple Grandin shows it absolutely beautifully. There's a scene in there where a whole bunch of shoes come up in rapid succession. I have to kind of narrate a picture that's in my mind. Oh, and it is on DVD, I've got to tell you that. But what that gerbil wants is it wants a place to hide. So you give it something to get under, guess what? It stops digging. A hen wants to lay her egg in a private place, in a secluded place where she can look out and watch. Why does she do that? Because in the wild, if she didn't lay her egg in a secluded place, she'd get eaten by predators. Now, you can measure behavioral motivation. You can measure how much does a hen want a private place to lay an egg. And some very clever experiments were done by Ian Duncan up in the University of Guelph, and he made a little doggy door for a hen to push through. And he trains her to go through the doggy door to get something she wants. Then he puts weight on it. How much weight will she lift to get to a nest box? How long is she willing to stay off feed to have a private nest box? A real long time. So you can put hard numbers on motivation. And polar bear, that's the high-seeking animal, the nomad animal. Has a high-seeking drive. So throwing a fish in all different places all day gives him things to do. Now the horse, on the other hand, is a high-fear animal. How do horses survive in the wild when they're living in the wild? They run from things, kick. But they're also got the eyes on the side of their head, and they're always vigilant, looking around, scanning the plains. And rapid movement tends to scare prey species animals like horses and cattle and deer, but rapid movement makes predators chase. You ever played with a laser pointer with a cat? It'll chase it all over the place. And so we got to be careful in working with training horses to not traumatize them. You know, people are getting away from rough training methods. I hate rough training methods. You know, some people will train a horse or a steer to lead by tie it up to a tree and just let it fight it out. Now, if you do that with a Holstein that's got a real low fear temperament, she'll pull back. It's not so bad. It's probably okay to do that to Holsteins. They just don't get that scared. But if you do that to a Solaire heifer, that's a real flighty kind of cattle, or an Arab mare, she pulls back and she doesn't habituate. She stays scared. There are differences in how stressed out they can get. Even in humans, you have this. You can either have a long or a short serotonin transporter gene. And people that have the long version of the serotonin transporter gene, you know, they get in a plane wreck. They don't get as stressed out about it as maybe someone with the short one. Now, I did some experiments back in the 80s. I always like to do stuff that other people haven't done before. Sometimes other people don't really appreciate that. And I was very interested in the research of Bill Grandin. And he found that when you put rats in an enriched environment where they have all kinds of old wood and junk to crawl on, they grow more little nerve endings in their visual cortex than rats living in a plastic shoebox in the lab. So I thought, let's try to use this as a welfare test, you know, for pigs that are in a commercial kind of barren big pig farm. So I said, let's look at the somatosensory cortex that goes with the snout. So I had pigs in just a regular little commercial pens, and I had litter mates over in Disneyland. Every day they got different toys. They got fresh straw every day. They loved fresh straw. Now, once they got the straw ripped up into pieces this long, they weren't interested in it anymore. And the hypothesis, going along with Bill Greenow's, all of his big, huge zillion dollars worth of grants, was that the pigs in the enriched environment would have more little branching in a little nerve endings. Because what Bill's hypothesis was, is complexity of environment makes little nerve endings grow. Guess what happened? My pigs in the barren environment had more nerve endings. And when I told my advisor that, he said, oh, shit. That was contrary to the hypothesis with zillions of dollars worth of grants. That's sometimes how science goes. So we repeated the experiment. This time we put video cameras in so we could find out what they were doing at 3 o'clock in the morning. Like if you're studying pain in animals, you've got to put video cameras in there that you can look at remotely. And a lot of the animal behavior software is really expensive. Security stuff's cheap. You can buy a really nice system for spying on animals and a software to go with it for a couple $1,000s. You just go to a security company. And you'll find things like mice that are doing somersaults at 3 o'clock in the morning. They're not doing that during the day when anybody's around. Well, in the middle of the night when no one is around, my pigs were grinding their noses into the floor. This was the barren environment pigs. They were grinding their noses into the water and grinding their noses into each other. It was use, not complexity. So this brings up the whole idea of bad neuron growth in the brain, you know, where the dendritic growth was bad. Well, I went against a whole lot of grants, and I found 2 papers that supported my hypothesis. One was where they made a cat lift up its paw. He called that paper a piece of shit. I'm not kidding, those were the exact words. And another paper I found was a bad study, and it never really got it published right. Went against a bit too many grants. But now it's known in neuroscience that, you know, things that you use in the brain get strengthened. That's the old Hebb synapse theory. And, you know, when I was a little kid and I was autistic, I used to like to sit and rock and do stereotypies. Well, if I'd been allowed to do that, I wouldn't be here now, because I think you could just build a dendrite highway where I'm not supposed to have one. When I was a little kid, loud sounds hurt my ears. A lot of animals have very, very sensitive hearing. They can hear high frequencies that we can't hear. You know, and then we're keeping them in environments that might be, you know, way, way, way too noisy. And when I was a little kid, the environment was sort of like living in a boiler factory or in the middle of, you know, a bunch of freight trains, you know, going by. And that hurt my ears. And I found that I could just sit and dribble sand through my hands and I could shut out the world. Well, that's kind of what my pigs were doing when they're grinding their noses into the floor. And it's like taking a drug. When you're doing stereotypies, you sort of drug yourself. Well, I wasn't allowed to do that. I had a lot of very good early intervention, and I would be dribbling sand through my hands, and then I'd get to studying every little grain of sand like a scientist studying it under the microscope. Now, another thing, working with animals and some individuals with autism and some other disorders is it's sensory-based, not word-based. You want to understand an animal, you got to get away from language. Can't emphasize that enough. Thinking pictures, sound, touch, smell. Shut your eyes. What does something feel like? What does it sound like? What does it taste like? What does it look like? And I didn't know when I was a lot younger that other people didn't think the same way I think. Until I wrote my book, Thinking in Pictures, in the mid-'90s. Well, we don't have somebody sleeping in the front row, do we? I don't allow that. I know, I get tired. Been there, done that. I've fallen asleep in meetings. Somebody criticized one of our presidents for falling asleep over in Europe at 4 o'clock in the afternoon. Been there, done that during a ethology meeting one time. Fell asleep in the back. I know what it's like. But, you know, you always assume that your thinking is like everybody else is thinking. And then I started questioning other people about how they think. And I got some like really surprising kind of revelations. And this is a question that I asked. And I'm going to ask this question, and then I'm going to explain to you why I asked this question the way I did. Think about a church steeple. How does it come into your mind? I was shocked to find out that a lot of people get a very vague, generalized one. I just see specific ones. I can name off where they're at. Now, why did I pick a church steeple? Because if I said house or car, most people can see their own house or car. I wanted to pick something that's out there in the environment, and everybody sees them. Also, just about everybody knows what they are. Ask your cell phone tower, you might not know what those look like. But that was really shocking. That a lot of people, it's much more vague. And I find a few people where there's no picture at all. And then I ask them if they can drive, and they say yes, so I know they're not blind. And they're an auditory thinker. I have found in autism that there's kind of 3 kinds of specialist minds. There's a photorealistic visual thinker like me. Think Google for pictures. Often can't do algebra. Another kind of mind is the pattern thinker. Kind of a more abstract visual thinker. Think origami. Think chess. Think organic chemistry molecules. Patterns. A lot of these kids have problems with things like writing composition. And then you can get word thinkers. You can get auditory thinkers. You can get mixtures of different kinds of thinking. You know, visual thinking is a continuum. Somebody asked me yesterday if I could be made into a word thinker. Well, I'm like here on this end of the continuum of visual thinking. And this person without visual thinking is here. Well, if I work on it, maybe I can get to here. But I'm not going to take this person and bring them to here. You know, if you're in the middle where most people are, yeah, you can, okay, I want you to, just think about those church steeples. Let's say you came up with a generalized one. Just start thinking about the specific ones. Now, that generalized steeple, that's an association cortex, in the visual cortex. And the one where you're thinking about the specific ones, that's primary visual cortex. And I had tensor imaging done on my brain. I have a huge internet cable goes all the way back into primary visual cortex. The control doesn't go back that far. I think in pictures. It's literally having movies inside your head. I've had teachers say to me, how do I get rid of the movies in the kid's head? Well, you can't. That's how he thinks. Now, there's some evidence that even in so-called normal people, language covers up things like mathematics, things like thinking in pictures. There's a type of Alzheimer's where the language parts of the brain get wrecked, the frontal cortex gets wrecked, and this artwork here came out of a patient that had no previous interest in art. There's also been some research that was done with Van Gogh's Starry Night. Now we got all the swirly things up in the sky, and some mathematicians got a hold of that and said it matched a statistical pattern of water turbulence. Well, I don't think Van Gogh was thinking about mathematics when he painted Starry Night. but he put mathematical patterns in it. Now, in some of my earliest work with animals, I'd get down in the chute and see what they're seeing. And in the early 70s, this was looked at like it was a nut. And this brings up the whole thing of, when you want to be a pioneer, the rest of the scientific world's going to think you're crazy. When Margulis, mentioned that the mitochondria at one time were free-living organisms, that was looked at as crazy. That's now known to be fact. And I go, okay, I'm down in the chute, the cattle going down this chute. Look at the shadows there. I can see people. If it's cloudy, you don't have the shadows. You got a chain hanging down. Then they're afraid of a chain hanging down. And I always get asked, do they know they're going to get slaughtered? And I found that they behaved exactly the same way at the slaughterhouse as they do in this vaccinating chute. They knew they were going to get slaughtered. They should have been jumping out. And the slaughter plant I went to only had a fence that was this high. And believe you me, Arizona striped Brahma cattle, they could have jumped over that fence, just hopped over it, but they didn't. Here's an animal coming out of a chute. See how he's looking right at that streak of light? Eyes and ears looking right at it. Watch where they're looking. In dogs and cats, the ears work together. That's because it's a predator. But in your grazing animals, horses and deer and cattle, the ears work independently. Watch your ear radar. Watch things like if the whites of the eyes show. You see the whites of the eyes, your animal's getting fearful and scared. In cattle and horses, tail switching if there's no flies, that's anxiety. Dogs, tail wagging, that's good. Unless it's really stiff and just the tip's going, that's not so good. When the whole butt's going like this, then they're really, really, really happy. But when cattle start to lash their tail like a cat, watch out. You're going to get kicked. Same thing with horses. I have been giving talks for 35 years on cattle handling. Why do I still have to keep showing a slide of chain hanging down in a chute? People don't take them out. It's like they don't see it. I have to make verbal checklists for all these things. I have a book on humane livestock handling. I have a whole list of all the things they need to look for to get out of the facilities. Watch your ear radar. Horse and the cow have got, the zebra and the horse have an ear on each other. Look at the other ear on me. Now, when they get really upset or scared, they just put them straight back. But when they're just sort of watching, just watch, they're looking at. This horse was deathly afraid of black cowboy hats because during a veterinary procedure, somebody threw alcohol in his eyes. And the person who did that was wearing a black hat. Now, notice a white cowboy hat has no effect. You see, the thing is, remember, animal thinking is sensory-based. A white hat's a different picture than a black hat. I put the hat down on the ground, and when I put the hat on the ground, it wasn't as scary. But then as the hat got closer and closer, I started bringing it up like this to my head. The more scary it got. And there was no way I could have been that distance from the horse and had the hat on my head. I just got it to my waist, and the horse wanted to start rearing. You see, as it got to be closer and closer to a match. Common things like a horse might be afraid of a guy with beards. Guy has a beard, or somebody that wears a white jacket. They'll make an association with something they were seeing or hearing right at the moment the bad thing happened. There was an elephant at a zoo that was deathly afraid of diesel-powered equipment. If it had a diesel engine, he was scared to death of it. If it had a gas engine, it was okay. Somebody probably worked him over with a backhoe or something. And so, had a diesel engine, that was a real bad thing. But a dog might get afraid of the place where he got hit by a car. Because this is where the association cortex of the animal is a little bit limited. We would know that the car is the thing that did it. Here are some examples of specific fear memories. Now, the thing is, in working with training animals, we've got to make sure we prevent fear memories. They're very difficult to get rid of. And the more high fear the animal is genetically, the more difficult it is to eliminate the fear memory. Because the problem is, you can train the brain to shut the file, but you can't erase it. Now there's some research showing maybe it can be erased if you give them propanolol, which is an old-fashioned blood pressure medicine that is being used now by the Army and research on post-traumatic stress syndrome. Now, you can also have touch memories. If you took two different kinds of horse bits, imagine one that's jointed and one that's straight, and I held them in my hands and shut my eyes, they would feel different. A jointed bit would feel different than a one-piece bit. And if a horse has been abused with a jointed bit, any jointed bit, he's going to go berserk. But if I get rid of a jointed bit and use a one-piece, where it's all solid one piece, then not jointed, he'll be fine with that. You see, this is where you get out of the fear memory file. There's some research that shows animal brains actually set up file folders. There's a paper in Science where a monkey was looking at kind of a computerized image of a dog, like a brass dog sculpture it looked like, and it would gradually morph into a cat. And as it gradually morphed into a cat, the monkey would press the switch, dog, 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 then all of a sudden switch to cat. You had a cat file folder and a dog file folder. In human beings, they found a neuron in some guy's brain during epilepsy surgery that responded to Bill Clinton, and another neuron that would respond to some movie actress. You know, that even in the human brain, you can get specific pictures. Dogs recognize the voice of the good person and the bad person. We did a lot of work at the Denver Zoo on training antelopes to cooperate with the veterinary procedures. So they would voluntarily cooperate with the blood test and not get all scared. One thing that we learned is the bad veterinarian that had shot him with a dart gun, he couldn't work with the trained animals. You could bring anybody in off the street, but the guy that had been the dart gun man, he couldn't get near him. It's very important for an animal that first experiences with new things be good first experiences. If the first time that horse goes on the horse trail or he falls on his butt, he's likely to be afraid of horse trailers. And a really common bad thing that horses do in horse trailers is when you open the door, they back out like a rocket. That's a horse that has bashed his head exiting, and he backs out like a rocket because if he thinks if he backs out fast, he can get out for the bad trailer, like knocks him on the head. See someone nodding their head there. The more flighty an animal is, the more gradually you have to introduce them to new things, more gradually and carefully. This is just some cortisol levels where there were no painful procedures done like dehorning, but beef cattle rough handling, deer netted. I've had wildlife biologists say, well, that deer can't be that stressed. We held it down for only 30 seconds. I said, yeah, but if you went out there and somebody like knocked you down and took your wallet, you'd be really, really stressed over that. Then you can see down there for cattle sleeping, and then our trained antelope. Our trained antelope had almost baseline levels of stress hormone because they weren't getting scared. See, this brings up another principle. When an animal voluntarily does something, it's really important, voluntarily cooperates, you don't get all the fear. Okay, up there on the top of the graph there, the rough handling, that's fear stress. It's just fear stress. No painful procedures were done other than taking a blood sample, and that's not really very painful. This is fear stress, and fear can be a really powerful stressor. And, you know, the thing that's interesting when you look at the literature is in the neuroscience literature, they will use that little four-letter F word, fear. But when you get over into the agricultural literature, in the veterinary literature, a lot of people didn't want to call it that. You know, but the circuits have been mapped. You know, some people don't want to admit that when they're handling these cattle, they are just scaring them half to death. This just shows our antelopes and how we trained them. And these animals are very specific in their thinking. Our trained animals, you could have strange people handle them, but one day the roofers came in, fixed the barn roof, and they panicked and cracked up on the fence. See, people on the barn roof is different than people in the barn and people out in front of the exhibit. You see, it's a different picture. See, even ants can store a graphics file. There's a paper called Multiple Stored Views. And when ants go out and forage, you know, they follow the pheromone trail. But they also take some snapshots along the way. And then when they come back home, they turn back and they're looking for a match on landmarks. And people say, well, how do you know an animal's a sensory-based thinker? Well, in neuroscience, we know visual stuff is stored in the visual parts of the brain, motor memories are in the motor part, auditory in the auditory part. Well, if they don't have verbal language, there's no other way they could possibly store information. It has to be sensory-based. Now, this is an interesting picture that a young autistic man drew for me. He's showing how there's little boxes in his head. This gets back to the file folders. How do I form a concept when I think in specific pictures? I don't think in generalized things. I think specifics. It's bottom-up thinking. It's bottom-up. Most people think top-down. The normal human mind, it tends to overgeneralize. My concept of a cat or a dog is based on a whole bunch of pictures put in this file or in that file. And when I was a real little kid, I differentiated a dog from a cat by size. Then our next door neighbor's got a dachshund. And I tried to figure out why Rosie the dachshund was not a cat. So I had to find a visual feature that she had that none of the cats had. Every dog, no matter how tiny, has the same nose. It's sensory-based. That's a visual similarity for categorization. Or I could use sound, barking or meowing. I could use smell. Dogs and cats smell differently. Man on a horse, man on the ground. In the mind of the horse, that's two different things. In the mind of cattle, it's two different things. You can have a situation where a rider's abused a horse. You can do everything on the ground. Veterinary work, shoeing, but you can't ride him. He's bucking and going crazy when you ride him. Or you can have a horse where they're fine for riding, like if you adopt a Mustang. They last time had a lot of bad stuff with people on the ground, so you can ride them just fine, but shoeing and veterinary work's like horrible, and just getting the tack-on's horrible. And then cattle that are just handled by horses, they might be very tame when you're on a horse, 2-foot flight zone. Then you try to move them in and out of a pen with a person on the ground. Now they got a 50-foot flight zone. They run over the person. Really dangerous. But you see a man on a horse and a man on the ground, that's two totally different things. It's a different picture. So you've got to think specific. I find in solving behavior problems, both with children with autism and with animals, people don't think specific enough. They'll say, my dog is nuts. The kid has behavior issues in the classroom. What's a behavior issue in the classroom? Does he giggle inappropriately, or did he haul off and hit the teacher? Is he throwing spitballs? You know, how I might work with those things is going to be different. Giggling in the classroom, I'm going to handle that in a different way than hitting the teacher. I find I have to ask, get more and more specific information. Neural mind drops out detail. Brain scan research that actually shows that. It was done by Nancy Minshew. She took people with autism, put them in a brain scanner and a functional MRI, and had them read out of a book. And just the part of the brain that goes with the words is lit up. Then they take Asperger, that's like a real mild, and you get the syntax and the words lit up. You put the normal person in there, guess what? The detail of the words disappears. You know, I think one of the big problems we have in a lot of policy things today, it's getting more and more abstractified. People are getting totally separated from how that policy is going to work down on the ground. On the leash, off the leash. In the mind of the dog, that's two different categories. When I'm on the leash, I protect my owner and I fight other dogs, and when I'm off the leash, I can go play with them. That's a very, very common thing that dogs do. Now, let's just look at things like you're going to the veterinarian. Give your animal a non-slip floor. Bring a bath mat in with a rubber backing on it so the animal's not slipping. Fear of falling, it's a primal fear, and your animal's going like this. I don't care if it's a horse or dog or cow. It's going like that. It's panicking. Jerky motion scares, both seeing it and feeling it. Steady motion. Also, there's an optimal pressure to hold an animal. You've got to hold it just tight enough so it feels held, but not so tight that it hurts. The mistake that people make is to squeeze them to it more and more and more when they panic. Oh, yesterday when I was at the zoo, I got to go behind the scenes at the penguin exhibit, and they picked up one of these little penguins about this high, and they held it around the middle, and then she supported its feet. So it felt completely supported, because she said, if I don't put my hand underneath their feet, then they panic. You see, that gets back to the fear of falling. We've got to prevent the fear of falling. A calm animal is easier to handle. Once an animal gets all scared, it takes 20 or 30 minutes for it to calm down. Let's not get it all excited. If the horse throws a fit in the veterinary clinic, let's give it half an hour to calm down. Should an owner be present during a veterinary procedure? Let's get back to how that animal emotionally perceives the situation. If the animal's scared, some little poodle and the owner's there calming it down, then the owner should be there. Okay, let's say the drug dealer brings in this pit bull. You want that drug dealer like 5 miles down the road. You don't want him in the lobby. You want him 5 miles down the road. Because in that situation, the dog may try to protect the owner against the veterinarian. But let's say the police bring in their German Shepherd dog, you know, that's police dog. Should the policeman need to be there? It's going to depend upon how he's trained. And if he's trained that when he's got the Kong toy, strange people can handle you, then the policeman should be there. Otherwise, he shouldn't be there. That's why you've got to look at motivation. How is the dog actually perceiving this? Does he feel he's got to protect the owner, or is the owner there to calm down fear? This just shows a squeeze chute holding cattle for vaccinations, and you want to squeeze on both sides so they don't get off balance. Now, one of my big frustrations in working with slaughter plants, some people in the industry call them harvest facilities. I think that's BS. I use the slaughter word. Even in Hollywood, I use the slaughter word. And one of the things I found at one of these great, big, huge, fancy press conferences was, people are just curious about what's going on. And, how does feed yards work and stuff like that. Now, when I first started out in my career, I thought I could fix everything with engineering. In the 70s, I could just build the perfect system. Now I found I can only fix half of it with engineering, because the other half's management. Good equipment's really important, but I got to have management to go with it. And I have found that 20% of people can be good stock people, but there's other people I can train, and I have to constantly supervise to keep bad, rough practices from slowly slipping back. And then there's some people that just shouldn't be handling with animals. And so the big thing I've been working on with the industry now is measuring animal handling. I can measure things like how many fall down. If you're a big slaughter plant and you want to pass the McDonald's audit, more than 1% of the cattle or the pigs fall down during handling, you fail the audit period. How many are squealing and mooing? How many are running? How many run into stuff? How many you use the electric prod on? This is stuff I can measure. And then I can tell, am I getting better or am I getting worse? You manage stuff that you measure. Well, this was baseline data that I took originally. Well, the places that were bad, 22% of the cattle were vocalizing. Horrible. And the plants with good handling, it was only 4.5%. Past the McDonald's audit, it's got to be down to 3%. You see, I collect the baseline data, I see what's the worst, and I see what's good. I knew that they could get down to 3%. Yeah, and then people handle cattle rough, you're going to have a lot more bruises. Well, one of the things I found is you got to make people pay for bruises. One of the biggest ways that you can make change in so many things is through pressure from retailers, large buyers. You want to get rid of sweatshops and things like that? Well, then you got to get the companies that buy the stuff to inspect the factories. I was horrified to read about some of the computer factories. People were jumping off the roof and killing themselves at computer factories. Well, we've got some computer companies here that need to get control of their supply chain management and find out what they're doing to their employees. Good equipment. This just shows some of my curved facilities. You might wonder, why make it curved? Cattle have a natural tendency to go back to where they came from. So you're just working with the behavior. But I found simple things, like putting a light on the entrance of a chute. Then they'd walk right into the slaughter plant. I didn't have the light there, they wouldn't walk in. Here's a very simple thing. I taped a light up over the entrance of the chute in this pig slaughter plant, and I went from 38% of the pigs having to be electrically prodded down to 4%. Now, of course, this is with well-trained people that only used it when the pigs refused to go. Inventing new equipment, I found, was a whole lot easier than teaching people how to use it. The thing that I have found all the years I've been working is people want the thing more than they want the management. They want the magic drug, the magic program. Oh, we're going to put internet in the schools, and that's going to make schools wonderful. Well, it didn't make schools wonderful. It's nice to have internet in the schools, but it doesn't replace good teaching. One of my big concerns right now in many things is we're lacking people, young people coming in and doing stuff out in the field. People who get interested in animal issues, they want to become lawyers. They're interested in environment, they want to become lawyers, sue everything. We got to figure out how to fix stuff. One thing I'm very concerned now in this country is we've gotten away from doing stuff. I'm a child of the 50s. We built the interstate highway system, we went to the moon. Republicans and Democrats, they both did good stuff like that. We need to get back to doing real things. How do we actually fix environmental problems? You can sue stuff, but then, okay, McDonald's had the power to kick plants off the approved supplier list, but then my job was to fix the plants. And out of 75 plants, I fixed most of them with simple things. Lighting, non-slip flooring, and covering up things where they could see people and vehicles going by and conveyors moving and things like that. And then there's totally new stuff that needs to be invented to deal with energy problems. We need people to figure out how to actually do stuff. I gave a talk at Pace University. A lot of their students go into finance. I said, we got to get back to doing stuff. I read an appalling thing in a business magazine. You know what venture capital is? Venture capital is when investors, give a big grant of money to a startup, some little startup company like Google, and then that turns into something really big, or they give it to lots of different kinds of companies, give startup money to startup tech companies. Well, when venture capital makes less profit than all of this derivatives and credit default nonsense, which I call casino gambling banking, we shouldn't even be doing it, that's really bad. We need to be getting back to the kind of things like that, how about figuring out ways to solve energy problems? Venture capital needs to be going into those kind of things. That's doing stuff. I always like to show my drawings off. Because when I was younger, people really thought I was weird. And the way I sold myself to people was I sold my work. I'd show off my work. That's how I sold jobs. Because I was really weird. Movies showed me in the 60s and 70s, and I was really weird before I started taking antidepressants. Does an animal actually think? Marion Stamp Dawkins defines thinking as solving a problem under new conditions. It's not simple associative learning, operant or classical conditioning. It's also not a hardwired instinctual behavior. Like birds when they mate, he struts around with his tail feathers up and she wiggles her butt and they kind of do a little dance, all hardwired, motivated by sex. That doesn't require thinking. If you rub a mare that has a foal right around the udder, she'll groom her baby, she'll also groom a gate. That's obviously not thinking. And simple associative learning doesn't really require thinking. But here's a situation where animal actually solved a problem. This crow figured out how to bend a little hook and make a little tool to snag a little bucket. This is Nicola Clayton. She's the Blue Jays, getting mixed up. Nicola Clayton's the Blue Jays. But this is solving a problem under new conditions. And here are the jays. This is Nicola Clayton's work. And a jay knows when another jay's watching when he's hiding his worm trees. Waits until another jay turns away, and then he'll hide it in a different compartment. But if it's a family member that's watching it, he lets family members watch. It's okay for family to rip off your worms, but not strangers. One of my really big concerns, I'm getting near the end of my talk now, is what I call overloading the animal's biological system. We push a dairy cow to milk and milk and milk. We push chickens to make more and more meat, and they get leg problems. We're breeding dogs for all kinds of stupid appearance traits. Now poodles are getting gut torsion. You got bulldogs that can barely walk. They can't breathe. They can't have their babies naturally. Talk about bad becoming normal. Okay, you push the dairy cow too hard, they get lame, they get too skinny, they only last for 2 years of milking. You can get dogs with neurological problems. Everybody thinks it's really pretty to have white, blue-eyed dogs. Put two of those together, you're going to get deafness and other kinds of really bad problems. And what happened to those pigs' ears? Another pig ate them. When the industry went to the lean line pigs, they accidentally bred a pig that was meaner and more excitable. Now, nobody deliberately wanted to breed an aggressive pig, but sometimes traits are linked. And they bred a more excitable, lean and mean pig. And I was one of the first people to notice this because I was going to the plants and I'd see pigs from many, many different places. See, the people that bred these pigs only looked at their own pigs. I was looking at everybody's pigs. So I saw the difference. And they'd say to me, well, you're not a geneticist. And I said, I got one qualification. I look at more pigs in more different places than you ever looked at. Yeah, traits are linked. Yeah, those are really pretty. But you overselect for a single trait, you're going to wreck your animal. I want to talk about the work that Belyaev did. You see how the wild fox, he's like long and slender, pointy nose. Well, the Russians wanted a tame fur fox that wouldn't like bite your head off. So they bred for a tame fur fox that would lick you rather than bite you. And they ended up with a border collie fox dog. I mean, who would have dreamed a fox would turn into a border collie? That's basically kind of what happened. Traits are linked. I'm also really concerned that a lot of pets, like dogs, are not getting enough socialization. It's very important to socialize puppies to toddlers. They got to learn that this little person is a person, or you can get into very dangerous prey drive stuff, where this is prey, and if this big, then it's a person. You got to get them socialized to toddlers, socialized to other dogs. You know, the leash laws we got in Fort Collins, there's a lot of work having a dog. Take it out and let it socialize off leash with other dogs. Animals reared alone often viciously fight other animals. I've seen that in dogs, I've seen it in cattle, and one of the most dangerous animals in the farmyard is the dairy bull. He's hand-reared, and when he gets to be sexually mature, he thinks he's a person. It's a mistaken identity issue. So then he views the people that raised him as a rival for mates and attacks. It's not a tameness issue, it's mistaken identity. Now, if you take the bull and you rear him on a cows, and they're all tame cows, you can pet them all you want, but he knows he's bovine and he's going to leave you alone. It's mistaken identity. Now, dogs, on the other hand, we've bred a really, really special animal in the dog. A really social animal that pays attention to where we're looking, pays attention to us more socially than a wolf does. Now we can become their leader. We can become part of the society, but the grazing animals, we just got to be the benevolent power. There are some of my books, and hopefully we got some time for some questions, because I always like to have some good discussion.